Hello students, today's topic is limit. Before we delve into the mathematical concept of limit, let's first consider the broader meaning of the word limit. A limit is essentially a boundary or restriction. It represents the greatest or smallest amount of something that is allowed or possible. So it is, generally speaking, it's a boundary or restriction that we apply on something. For example, it tells us how far something can go, whether it's speed, time, or even our own action. For example, you may be allowed to take an exam for 3 hours, right? So the limit of your exam is 3 hours, and that could also have a time limit like 9 to 12 or something. Okay, but it's important to remember that a limit always apply to something specific, like we need to apply it on something. It's not just a vague idea, it's a rule or constant placed on a particular object or action. Otherwise it doesn't mean anything. For example, a speed limit applies to how fast a car can go. For example, on a highway, the speed limit of a car is 100 kilometer per hour. So this is the limit apply on the car on a highway, right? Simply a time limit applies to how long you can work on a task, right? You may be given to a project in your school and the due time could be any date. So that is the limit that your teacher gave you to do the assignment. Okay, so the limit. So what do we learn? That limit is not a vague idea. It has to be applied on something or some general meaning of the limit is this. Now, in mathematics, we use the concept of a limit in a very precise way. Just as in life, where limit defines boundary in mathematics, we apply limits to function. So let's understand what the limit of a function mean and how we use it in mathematics. What is the use? We'll see that. So to understand the concept of limit, let's consider an example. Consider a function fx as x squared minus 4 divided by x minus 2, where x is not equal to 2. So it is obvious that why we are taking x not equal to 2. It is because if x is equal to 2, then the denominator would be 0 and the function would not be defined. Now let's write it as x plus 2, x minus 2, and the denominator is x minus 2, x not equal to 2. Now Since x is not equal to 2, we can cancel these factors. Now see, if x would be equal to 2, then x minus 2 would be 2 minus 2, and x minus 2 again 2 minus 2. So this would be 0 by 0. So you cannot cancel these two. You can only cancel this if and only if x is not equal to 2. So since x is not equal to 2, we can cancel, these two can be cancelled out, and we get x plus 2, x not equal to 2. So actually our function is this. Now, the function is not defined on x is equal to 2. Every other place it is defined. But can we take an idea what would be the meaning of the function at x is equal to 2? So this is where your limit comes in handy. Okay. Okay. So we have this function fx is equal to x plus 2, x not equal to 2. So obviously at every other point we know the value of function. At 1 it is 3. At 1.5 it is 1.5 plus 2. At 1.7 it is 1.7 plus 2. At root 2 it is root 2 plus 2. But we don't know the value of the function at x is equal to c. And we want to see what would be the, we want to take an idea what should be the value of the function when it is approaching to 2. So let's take that, because x can never be 2. So we can only take the idea. Now let's see this, the graph of this function. So at x is equal to 1, at x is equal to 1, your fx is 3. So this is x axis, this is y or fx. So at x is equal to 1, your function is 3. At x is equal to 0, your function is 2. Right? Fx could be 2, x should not be 2. So at x is equal to 0, your function is 2. So it, and at 2 it doesn't, we don't know what's the value, right? So this is a line, we just don't know what should be the value at x is equal to 2. But we want to take an idea what would be the value at x is equal to 2, right? At x is equal to 3, it is 5, right? 3 plus 2, 5. Now let's see. At x is equal to 1, we can see that the value of your function is 3. We can also see it from graph. At x is equal to 1.1, let's say it is 3 point. At x is equal to 1.5, it is 3.5. At x is equal to 1.9, and x is 1.9, the function is 3.9. At x is equal to 1.99, the function is 3.99, right? At x is equal to 1.999, your function is 3.999. So as x is approaching to 2, can you see where your function is approaching? This is approaching to 4. You can see it from here also, and you can see it from graph also. So when your x is approaching to 2, your fx is approaching to 4, right? This is what we see. But when you are on a real line and you have a point, how many ways can you approach to this point? You can either go from this side, or you can also move from this side, right? If you move from this side to this side, so you are moving from left to the point. So this is called from left to the, uh, you know, from left to that point. And if you move from this side, you will move from right to the point, right? So closely, the limit we just talk about of the point x is equal to 2, we were always to the left of 2, right? The value of x was always less than 2. Either it was 1.1, 1.2, 1.5, 1.9, 1.99, 1.999. All these points were below 2. So they were always left to the 2. They were always 2 minus something, right? They were always short of 2. So you can say that 2 minus something. X was always 2 minus something. And then your when we were approaching from this side, the function was going to 4 side. But we have another side. We can also move from 3 to 2, right? So we can also move from right uh, to the point 2, right? So let's see. When you were at x is equal to 3, the value of your function was 5. When you are at x is equal to 2.5, your fx would be, fx was x plus 2. So this would be 4.5. When x is 2.2, your fx would be 4.2. When fx is 2.1, your fx would be 4.1. When fx is 2.001, your fx would be 4.001. So now let's see it on the graph also. Let's erase these things so that the graph is clear. Okay. So when you are at x is equal to 3, your function at x is equal to 5. When you are at 2.5, your function is 4.5. So if you look closely, as you are approaching x is equal to 2, the value of your function is approaching to 4. So here the value of x is always 2 plus something, right? So when your x, and it can never be 2. So when our x is 2 plus something and it is approaching to 2 from right. So it means it is approaching to the point 2 from right because it is always 2 plus something. Your function is approaching to 4. Now we can say that when x is approaching to 2, when x is approaching to 2 from left side, the value of your function is 4. Similarly, when x is approaching to 2 from right side, the value of function is again 4. So we can also say when x is approaching to 2, the value of function is 4 because when x is approaching to 2, it has two meanings, from left side or from right side. So if someone asks, when you say the statement when x is approaching to 2, and if they when you say the statement that when x is approaching to 2, the value of your function is 4, if anyone asks from which side, you can say from either of the side, right? So when you have this liberty that your answer is from either of the side, then we say that yes, the so when we have this liberty that we can say from either side, where from either side you approach to a point, the limit is same, then we say that the limit exists. So, what does it mean that x is approaching from right side? So let's first see what does it mean where that x is approaching from left side to 2. In this case, it is 2. Sorry. So we have this line and this is the point. So when your x was approaching from 2, that is, it was 1 and then 1.5, then 1.9, then 1.9999. These things, so it was always less than 2. So it was approaching from left side. So your x was approaching to 2, but it was always 2 minus something, right? So it was approaching to 2 from left side, and this is your notation. So when x is approaching to 2 from left side, the limit of fx is 4. So this is how you write it. When x is approaching to 2 from left side, the limit of the function is 4. Similarly, when your x is approaching 2 from right side, so it is always 2 plus something, right? The limit of your function is 4. So we can also say that limit x approaching to 2 fx is 4. And if someone asks from this side, from which side, we can say from either side. And it contains the meaning that x from left side and x from right side, the limit is same. So this is what the concept of limit is. So suppose if you take a general point a, okay, and we need to find the limit of a function fx at x is equal to say a. So we say that the limit of fx is exists at x is equal to a if and only if limit x, when x is approaching from left side, the limit of the function is same when it is approaching from the right side. Okay, this is your LHL, means left hand limit, and this is your right hand limit. So the limit would exist if and only if the left hand limit and the right hand limit are same. This is called concept of limit. I hope this is clear. Now suppose you have a function like this. Fx is 1 if x is greater than or equal to 0, and it is minus 1 if your x is less than 0. Okay, so let's see the graph of this function. Let's make it over here. When your x is greater than 0, so this is 0, to the right side of the x, whenever x is greater than 0, the value of fx is 1. And whenever it is less than 0, the value of fx is minus 1. So whenever x is less than 0, the value of fx is minus 1. And at x is equal to 0, the value of fx is 1. It is not minus 1. So that's why I draw a blank circle over here. Now this function is piecewise. So this function is called piecewise function because we define this function in pieces. So we define it in pieces. When your x was greater than or equal to 0, the function was, the value of the function is 1, and when x is less than 0, the value of the function is minus 1. So your previous function, our previous function was not a piecewise function. Our previous function was fx is equal to x square minus 4 divided by x minus 2 when x is not equal to 2. So we didn't say what would be the value of x when x is 2. So this is not a piecewise function. However, if we would have defined it like if x is 2, then value of fx is something, let's say 4. You can also say 5. It still would be a function, right? So let's say that the value of function is 4. Then this would be piecewise function because we give the information of the function in pieces. So this is what we called a piecewise function. Okay, let's erase this. Yeah. So x is less than 0. Now let's see the limit of this function when x is tending to 0. Does it exist or it doesn't exist? And if it is exist, what should be the value of the function? Now, when x is, no, we need to find the limit of the function, means we need to find what should be the value of fx when x is approaching to 0, right? So it should be our habit that we should all ask the question, then from which side we are approaching our x. So suppose we are approaching from left side. So when x is approaching from left side, so it means the value of x is always less than 0. So we can see when the value of x is 0, the value of function is always minus 1, right? So when x is approaching to 0, from the left side, the value of your function is minus 1. And when x is approaching from right side, from this side, the value of your function is always 1. So then the limit is 1. It means now we cannot say, now when we write limit x tending to 0 fx, what should we write? If we would write it as 1, and someone asks from which side, we cannot say from either side, but because it is not from left side, it is not 1. And if we write it as minus 1, again we cannot say from either side because the value from right hand side is not minus 1, it is 1. So now we don't have the liberty that we can answer this question that from either side, right? So it is minus 1 from left side. So left hand limit is minus 1 and right hand limit is plus 1. It means that left hand limit is not equal to right hand limit, which was an essential condition for the existence of limit, right? So the limit of this function does not exist. Sorry. The limit of the function does not exist. There are many times when students get confused that limit of the function at some point and the value of the function at that point are the same thing. So when we are saying limit of the function at a point, we mean limit x tends to a fx. So it includes that the left hand limit and right hand limit are same. And when we see the value of function at fx, we mean f of a. So suppose f of x is equal to x plus 1. So if you want to calculate f of 1, it would be simply be 2. But if you would calculate limit x tends to 1, x plus 1, it will also be 2. So sometimes students get confused and they think that limit of the function at a particular point is same as the value of the function at that point. But they are not always same. So let's see, they may be same or they may not be same. So we are not sure. We always need to find. So to understand this, let's take an example. Let's suppose we have this function fx is equal to 2 when x is not equal to 0, and it is, let's just say that it is 1 when x is equal to 0. Okay, now let's see the graph of this function. Just a second. So let's make a small graph over there. When x is not equal to 0, so from here to here, just not equal to 0, at not equal to 0. So this should be a blank point. The limit is, the value of the function is 2. Okay. But at x is equal to 0, the value of the function is 1. Now let's see what should be limit x tends to 0. Of course, at x is equal to 0, the value of function is 1. So it means f of 0 is 1. But when x is approaching from left side, so whenever x is less than 0, the value of your function is always 2. And when x is approaching from right side, that is from here, again the value of your function is always 2. So your left hand limit and right hand limit are same. So it means we can say that limit x tends to 0 fx is 2, because the existence of limit, the concept of existence of limit is that your left hand limit and right hand limit should be same. But this is not equal to f of 0. So from this example, we can say that limit x tends to a, fx is not same as f of a, but it could be same in some cases. Let's see that case. Suppose we have this function. Let's take a very simple function. Let's take fx is equal to x square. All these are are examples from NCERT class 11 book. So suppose we have this function fx is equal to x square. So let's see the graph of this function. Okay, at x is equal to 0, this is 0. At x is equal to 1, it is 1. At x is equal to minus 1, it is 1. Right? So this is how the graph should be drawn. Now let's see the value of this function. We can find it at any point. Let's find it at x is equal to 2. So when x is 2, okay, means this point, right? What would be the value of this function? So when x is 2, your fx will be 2 square or 4, right? So when we approach from left side, right, we can see that fx is approaching upwards toward 4. And when we approach from left side, we can see that your fx is moving upwards to 4. And when, suppose we are approaching to the right side, right, we can see again that our fx is moving towards 4. We are just understanding it from, so from both sides, when from left side of 2 and from the right side of 2, when we are moving from left side, we can see that our function is moving to 4. And when we are moving from right side to the point 2, again the function is moving to 4. So we get that your LHL, that is limit, when x is approaching to left side, is 4. And our right hand limit, that is limit when x is approaching from right side, the limit is again 4. So limit exists and it is equal to 4. Now f of 2 is also 4, right? If you put x as is equal to 2, it is also 4. So it means, what does it mean? It means when you were moving towards the left to the 2, the function was moving to 4. From right also, it was moving to 4. And at at x is equal to 2, the function was 4. So this is what we call continuous function. Continuous function. When your limit exists and it is same as the value of function at that point, we say that this function is continuous. So it does not need to be always continuous. When the function is continuous, this will happen. If this happens, it means function is continuous. Continuous means when you are drawing the graph, you do not need to lift your pen at that point, right? So at x is equal to 2, it is continuous. So when you were drawing this graph at x is equal to 2, you didn't need to put up your pen. While in our previous examples, if you remember, all the examples, it was a discontinuous functions. So for example, from here also, when we were when we were making the graph, here we need to lift our pen and then continue. So at x is equal to 0, your function was not continuous, right? Similarly, here also, when we were making this graph, we were moving it like this, and at x is equal to 0, you need to lift your pen and then move it like this. So these are the example of non-continuous function. That's it for the introduction.